Well, I've seen it all now. Records used for packing. Not exactly sure what that will do, but I suppose it's one way of getting rid of your crappy record collection. Oh, it's Major Barley Mow. Stereophonic records. Demonstration test record. That might be interesting. Well, that's one. What have we got here? The Jungle Book. Ah, that's alright if anyone's got a record player and a child. That's probably a keep one. The King Singer's Lollipops. Big Western movie themes. You've got Lee Marvin, Wandering Star on that. I like that. Butch Cassidy and Sundance Kid. True Grit. What else we got? A few dollars more. Once Upon a Time in the Wild Wild West. I don't know if they're by the original artists, but we've got a few more here somewhere. Here we go. This side here. Pavarotti's Greatest Hits. I was expecting that to be a single. Okay, so what have we got in here then? Well, that's the case. Let's get it out of the box and I'll show you. Okay, this is it on the bench. Another amplifier. This is one of the, not one of the first amplifiers, but probably one of the first really good amplifiers I ever owned. Now I've been looking out for one on eBay for a long time that's a reasonable price, and they're usually very collectible, and there aren't many about. There seem to be quite a few in the States, but there don't seem to be so many over here. Most of you are familiar with the Marantz brand, I'm sure, and this is one of the amplifiers from the 1970s era. I don't know if anyone can guess what it is, but it is renowned for its high performance and very good sound quality, and hence has got quite a good following, and quite a lot of people out there are after them, and there have been lots of restoration videos done on YouTube and on the internet of people restoring them, and I picked this one up on eBay in non-working condition, or not correctly working condition, for a very good sum. And here it is. Probably one of the most attractive amplifiers of them all. This is the Marantz. Here you go, so you can get it in the frame. 1060. Now, as I say, I had one of these when I was younger. Sorry about that. My friend's mother bought one from the hi-fi shop that I was working at when I left school, and we were very impressed with how lovely it sounded, and I think a bit blown away by all the good reviews all the magazines were giving it. It's in pretty good nick. It's got a slight scratch mark there you can hardly see, and I think I could probably do something with that to actually hide that fairly well. So circa 1975, it's about 38 watts RMS per channel into 8 ohms. You see on the back, it's got the press-on type click terminals here, and you can see that, and separate phono stage inputs. It's capacitor coupled output stage on these amplifiers, and by what that means is the power supply is only a single rail supply. We've got one electrolytic in here that supplies the unregulated supply for the power amplifiers at about 80 volts. So because the because there is no you haven't got a plus or minus rail, you haven't got a plus rail and a minus rail, in between you need, if you have a plus and minus rail in between the two transistors, you've got a 0 volt connection, so you can draw that straight out to the speakers. But if you've got a plus rail and a 0 volts, those transistors are sitting at half potential, so you need a capacitor to decouple block that DC to your speakers. Now, mostly that's fine, that's not a problem, but the end result is that these amplifiers suffer from a switch-on thump. If you turn the amplifier on and turn the speakers on, you're going to clonk, and I'll demonstrate that in a minute. but basically all that is when you turn the amplifier on, the capacitor, one end of the capacitor is raised to 38, about 35 volts, something like that. A bit more than that, about 40 volts. And the other end of the capacitor's got no connection, apart from a very high impedance bleed-off resistor. So when you press the speakers on, it basically the speakers short out the end of the capacitor and force the capacitor to charge, but the resulting current flow is the thump you hear on the speakers. And I have actually damaged high impedance headphones with my Marantz amplifier by actually doing that. The sensitive headphones can be very susceptible to having DC pass through them, as can any transducer really. So let's pop the top off and have a look and see what it looks like inside. Okay, and here's the inside. Transformer, input fusing. We've got a pre-regulator in here for the preamplifier that sits under this fuse box. Filtering switches, tone control, PCB, and filter and mono switch connections here. This is preamplifier section here, phono preamplifier here, and this is the power stage that you see at the back here. You can also see that there's some dates on the capacitors. It looks like the 31st of April 1974. So this is the 7,000, I think 7,800, 7,500 microfarad at 100 volts or 80 volts. That's the main smoothing capacitor, single rail, so it only needs one. These are the DC blocking capacitors that are on the outputs of the speakers. TO3 devices on the output. You can see around the back here. You can see the TO3s on the back. All looks pretty original to me. Apparently it's had some feet replaced on the bottom. I don't know about that, we'll have a look at that in a moment, but inside it looks pretty unmolested. You've got trim pots here for symmetrical clipping, because obviously there's no DC offset adjustment because it's a capacitor coupled amplifier, and quiescent current settings for the output stage. Now the other way you can do this with the DC or the midpoint, the symmetrical clipping, is what you can do is take the supply voltage from the capacitor, divide that by 2 and set that on the input of the capacitor, the red connection relative to ground, and that should set your midpoint on your amplifier. That's one other way you can do it. I like to do it with symmetrical the symmetrical clipping. You can see exactly where you want to set it, and it's easy enough to do. Let's go around the back and have a look. So we've got our DIN plug for our tape monitors. We've got phono input here. Now this, apparently from what I've read, is the phono amplifier, and this has got a really good equalization curve and sort of gives a very nice tone. I've got a tape input. That could also be a compact disc player. That all these levels are the same level, all the same line level, except the phono input, which has got a 47k input resistance, and it's got RIA equalization on the much lower input level. We've got our switch sockets out here. That's something you don't see anymore, and these are the 2-pin American plug type, and they used to be great for turning on tuners and things. Obviously you turn the whole off, you turn the amplifier off, you turn the whole thing together. You've got speaker switches here. These are capable of being wired in parallel. I think you're limited to 216 ohms in parallel. I think it will actually run 4 ohms, but you don't get any, or don't get much of a power advantage. So that's the back panel. So these are Elner capacitors, and there you see that's an 80 volts. Oh, it's 4,700 microfarad. That is very small value for an amplifier of this power. And you can actually physically fit a 100 volt 10,000 microfarad capacitor in here of the same size. So that's probably what we'll end up doing. We're replacing those with larger value. The decoupling caps here are, I think they're 3,000 at 55. They will be replaced with probably 5,600 or 6.8, something like at about 63 volts. They'll fit in nicely. The advantage of going slightly larger gives you a very slight improvement in low frequency response into low impedance loads, because the capacitor's transparent basically to AC signal. The current AC signal will pass straight through, but as you get lower and lower frequency, the capacitor starts to try and block the signal, because you're basically starting to get almost like close to DC. So these capacitors will try and prevent that from passing. So if you can put a higher value capacitor in, you will get some advantage to a low frequency drive. The plan will be to strip this amplifier and totally replace all the capacitors. Now these capacitors are all old and they're all going to be dry. There's no point in, I'm going to power it up just to see what it does, because apparently the seller says it will work on one channel at low level. So I think what we'll do is we'll power it up, see if it's just simply a faulty, dirty contact on the switch, or is something a bit more sinister going on. Maybe an output stage is blown on one side, or the preamp's not working. So I'll plumb it up and we'll have a go and see what we get. Okay, we're all powered up. I'm running it through the dim bulbs just in case there's a problem with the output stage. This is a 42 watt bulb, so let's switch the amplifier on and you'll see the dim bulb. Yeah, that's good, so the light's gone dim. I've got a very dim light here. This usually lights up a nice blue sort of coloured LED, light blue LED, so we'll need to replace that because that's obviously a bit dim, unless it's not getting a full supply. So turn the speakers on. That's the click I was telling you about. I think we're on auxiliary 1. Okay, got one channel working. Left and right around the way. Okay, just dirty contacts in the switch. All the pots need cleaning. So it's clearly working fine. There's probably not a lot wrong with it really, apart from it needs a jolly good service. You usually get this sort of thing, and it's quite nice to find that the customer says, or the seller says it's only working on one channel. When you get it, you realise, or you know already, that it's more than likely just dirty contacts. So this is the first part of the restoration of this lovely Marantz 1060. I'm going to see what I can do about that scratch mark. You can hardly see, you can just about see it there. You can also see I've cleaned up with a bit of isopropyl. It's a bit yellow around the edges, so it's been a smoker's amplifier at some point, and it stinks a bit of nicotine and things. But it looks generally in pretty good, for its age, pretty good condition. We'll get the front panel off and we'll store that away whilst we rebuild the amplifier. They come off with these 4 screws here. That's not a problem. We can get that away, maybe take that into work and see if we can do anything with that. This is an allochromed front panel, so there might not be anything you can do with it. Incidentally, I did spot on eBay that someone's selling a black, making his own panels in black for this, and I must admit it looked pretty stunning, but I don't think I want that. I want to keep this amplifier looking as it should do. So this is the first part of the video, and the second part will follow. Okay, I've removed the front panel and a bit of a clean up with isopropyl, and I washed out all the sort of dust and dirt off the boards. I want to get on the compressed air line just to get rid of the excess, but it's come up pretty clean actually, and this is the underside. These are the decoupling capacitors from the amplifier, the main capacitor, output capacitor here. I've got some replacement capacitors actually from work. These are Chemet 4700s at 63, the right size. These were actually written off at work because the threads have been pulled out by one of our less careful engineers who managed to strip the threads out of these. So I've retapped these with M6 so they can go in there. So that's 4763 to replace 3000 at 55, I think it is. So that leaves the main electrolytic to be replaced. I've got to find something for that. I'll have to buy something for that probably, because I have a few electrolytics lying around, but they're all quite old, and it's no point in replacing it with an old capacitor when this one's probably still fairly functional anyway. And then of course it will be a case of getting all the capacitors together and finding what I need. A lot of these are ceramic and polyester, so I think these must be polyester. I doubt they'd use ceramic. There are also a few ceramic capacitors here. That's generally a no-no in an audio amplifier, but it says a lot when this amplifier's got such a renowned, a good reputation for high quality sound, and they're using ceramics and no one's ever said anything about it here. These are polyesters here. These are never any problem. None of these it's only the electrolytics that are going to be a problem with this amplifier. So these three will go. The power supply, the pre-regulator for the preamplifier and phono stage they'll change those as with the power amplifier. And you can see here that this is, I think I seem to remember my old Marantz 1060 had the same thing. There's got one manufacturer one side and another manufacturer, this is a Mitsubushi capacitor, this the other side, and this is a Toa, whatever these are. They're probably crap, but you never know, they might be working fine. So it's going to be a full recap, and then I'm going to also another thing that apparently someone said and told me, there's the capacitors. Let me put a light on here so you can see. These TO3 transistors haven't got any heat sink compounds. Now that one clearly has, and that's a Hitachi device. These are the Hitachi devices. The other ones are often Toshiba apparently, but looks like that one's may have been replaced. You see the heat sink compounds a bit smeary on that one, and that screw head on that one, it's a bit glary with that. That's the thing. You can see that head looks like it's a bit worn, like someone's maybe had the transistors out of it, and they fit in sockets actually, so they should just unplug, which is quite nice. So I need to check that all those screws are tight on the clips, because what also happens is with age these capacitors loosen off. I keep saying capacitors. These transistors loosen off, and that's the collector connection you see on the top here with the screw in it. So you need to make sure they're tight and the insulation's good. So that these amplifiers will all come out, and you see that's the thermal sensing diode for the bias control. Basically prevents thermal runaway. So yep, let's we'll get the components on order, and we'll go from there. Right, I'm just checking the ESR, these output capacitors. These are the ones I'm more interested in at the moment, with the LCR meter. Just see what figures we get. Now they're basically out of circuit because the speakers are switched off, so there's no connection apart from a high resistance bleed resistor. So that's one channel. Let's wait for the meter to auto range, and we've got 3,600 microfarad with a dissipation of 0.92, and that's at 120 hertz. So that cap shows good condition actually. Let's go to the other channel. See what we get there. Once it's sorted its range out, okay, that's slightly better. 3,300 and 0.83. So these two caps on the output stage look in pretty nice nick. They're certainly not dried up. So I'm going to compare it now with the Camet I plan to put in to replace those two capacitors. And let's see what we get with those. So this is a 4,700 at 63. And you see there the ESR, or the dissipation factor, is very similar. Obviously just the only difference is high value. So those caps are in really good condition. So I'm starting to wonder if it's worth changing them just for the sake of it. The next thing will be to check the output capacitor, which is I think we confirmed that was a 4,700, which is, I will change that. Whatever happens, that will be changed, even if that registers well, because that capacitor could do with a higher value. Easy enough to put a 10,000 mic in there. So I'm not even going to consider leaving that in. I might consider leaving those output capacitors in. They look pretty good. And obviously the rest of these capacitors here will be changed, because these are prone to failure and vomit electrolyte all over the board and damage the boards and things like that. So they'll be changed pro rata sort of thing. Okay, so let's carry on and start taking the capacitors out.